Example 7, we need to solve the triangle if the measure of angle C is 47 degrees, A is 10, and C is 16. So we'll draw a little diagram. Whoops, that didn't quite make it. So we'll get rid of that. And then we've got C being 47 degrees. Let's do A over here. So A will be 10. And then we've got, maybe we'll make this B here. Doesn't really tell you what it is, but we'll just go with the ABC. B we don't know, but C we know is 16. Be careful with this one, because we've got an angle side-side, or a side-side angle. So we definitely need to investigate case 1 and case 2. In either of these cases, the measure of angle C is going to be 47 degrees. And also the other sides will stay the same. Let's see what happens when we use the law of sines to figure out angle A. So we've got the sine of A over its opposite side is equal to the sine of angle C, which is 47, over its opposite side. Multiply by 10 on each side. And then we're going to need to do the inverse sine here. So this will be the inverse sine of 10 sine 47, and then divide by 16. Whoops, that's supposed to be 16. Alright, let's see what we get. 27.2. So we think the measure of angle A for this one is about 27.2 degrees. Remember, when we're looking for the other angle A in the second possibility, we just need to do 180 minus that angle. Those two angles will be supplementary. So we get 152.8. If we do 180 minus 47 minus 27.2, we'll find that other angle. And let's see, this measure of angle B should be about 105.8 degrees. This measure of angle B will be 180 minus 47 minus 152.8, which is negative 19.8. Wait a minute, we're not on the coordinate plane. There's no negative angles in a triangle that's just out there in existence like this one is. So this is a case where the measure of angle A and the measure of angle C are more than 180 degrees, which means that this case actually is not possible. We just have to worry about this first case. Remember, we were also given that A is equal to 10 and C is equal to 16, so all we really need to do is find B. When I'm finding B, I like to use as much of what we were given as possible. We were given angle C and side C, so we'll use that. We also know an approximate for angle B, and we're trying to find its opposite side. So here's how this law of sines is going to look. Sine of B, which is 105.8. Why don't we fill that in while we can? And that's going to be over B. And that's going to be equal to the sine of 47 degrees over 16. It's nice to start this when you have B in the top, so you can flip these right now if you want, but I'll show you that it will work either way you do it. You can multiply by B on each side. So you've got B times the sine of 105.8, and that's equal to, that would be wrong, sorry. That cancels. We have sine of 152.8. Then we've got B times the sine of 47 degrees over 16. We could multiply by the reciprocal on each side. So we'll multiply this by 16 over sine of 47. And we can see that B will be equal to 16 sine of 105.8 over sine of 47. So let's see what happens when we type this into our calculator. 16 sine of 105.8. Close it up, and then we're going to do divided by sine of 47. Notice we're looking for a side length, so we don't use the inverse. We use our regular sine functions. And we get 21.1 for that. So B is about 21.1. Let's see if that makes context in this case. The lowest angle is A, so A is the lowest side, that's cool. C is the middle angle, so the side opposite's in the middle. And then B is the largest angle, and so its side opposite will also be the largest angle. So this one does make sense. Yes, it is an angle side-side or a side-side angle, but we investigated it and we found that there's only one possibility. So you just have to solve for all the missing elements in that one possibility.